Thanks for an interesting talk and very intimidating, especially to people who are passionate about 4IR. So what I'm trying to do as part of my master's to just summarize that, I think it's about 8 words, 10 words. I think the society is just an integrated cluster that needs to be unpacked. And I'm trying to come up with a way of unpacking this integrated cluster and making sure that we can contextualize different fields and what they mean in the context of AI or computational intelligence, depending on what you like to call it, or the fourth industrial revolution. So my supervisor is Dr. Kacheni, and this is me, and you've heard about me. The start of the research really came from my master's, which was delivered in Austria. So they decided maybe I should unpack this thing a little bit more. And we also registered a patent, which is currently provisional. It is unpacking this. What I'm going to look at is, what do we mean by state abstraction and context? So I'm introducing a new concept there, which is called context-oriented solutionism, which means you're trying to come up with a solution looking at the context that you find yourself in. It could be nanoscience, it could be anything, but you need to come up with a solution that actually makes sense in the context of that environment. Then I have I'll briefly talk about an algorithm I introduced. This algorithm uses my indigenous name, the Indidielo. Indidielo is an amalgamation of things. It's actually a Zulu. It's derived from Zulu. So it's an Indidielo multi-agent optimization algorithm that I'm introducing, which is actually looking at 4 different agents that are interacting together to try and resolve a specific problem. Then I'm going to look at the agent-specific programming context. So this is in relation to this Indidielo I just introduced. Then I'll look at evolutionary thinking. Then I'll look at the integrative perspective, which is going to look at how we can integrate current careers. Not all the careers, hopefully maybe all. It would depend how you unpack the research, as it is still ongoing. Hopefully I'll be handing in this next week. What is state abstraction? State abstraction is really just looking at anything. Anything. We live in a state, and we design systems. We design systems that are 4IR driven, that are based on software. They use, in the context of this research, they use 5 variables. And these variables actually do sort of unpack what we mean by an integrative cluster. The first variable that actually drives this is discover. So unfortunately, you can't see that, but that is just discover, which is, if we're looking at an agent, it actually looks at how it discovers where it is sitting or where it is. You could look at yourself as an agent and look at how you discover, and you found your way into here. Then you actually went through construction. You constructed the path believe it or not, you actually preconceived this and you constructed that path that you actually drove until you got here. But then you also created governance mechanisms which actually were sort of crystallizing what you discovered and constructed, and all of that would then be kept, you'd keep on managing that through a cognitive architecture. Cognitive architecture actually uses senses, which could be your eyes, it could be your hands, it could be your feet. That is why we have the integrated cluster that we look at. And we just gave you what the Industry 4.0 means in the context of, I hope you can see that I'm not going to read, but it is talking about all of those different steps there and saying how they are actually integrated together to deliver. You could be thinking of a system. I was introduced as an architect on payments integration architect, even though the last project I did on payments was at least a year ago. But what we are doing really is just developing software. I said to you when I introduced the topic that we are all agents. And if you are an agent, you are actually sitting here, and when you are looking at me, I'm in a computational space. I live in a computational space. There's, believe it or not, there's algorithms, and you can actually find my coordinates. I can find your coordinates versus where I'm standing in relation to where you are. And that is how we actually make sense. And I call this the computational intelligence horizon, which is actually driven by Markov principles. And that is it's a lot of statistics and maths. And for us to go on and understand this, we use properties of abstraction. Unfortunately, again, you can't see that, but that is just leadership, which means there should be someone leading something. But we also, this is risk optimization, and this is this is a geopolitical context, which means where are you? Are you in Russia? Are you fighting with America? Are you in China? So you look at the geopolitical setting that you are trying to resolve the problem you are trying to work on. And the last thing is evolution and revolution, which actually looks at the first industrial revolution up to the current industrial revolution. Maybe the word fourth industrial revolution is not ideal because it creates an impression that we are going to have a fifth industrial revolution. We are not going to have a fifth industrial revolution. We are just going to keep on unpacking this integrated cluster that we live in. And if you sit in an organization, then you could be sitting at a strategic level, tactical level, or operational level, trying to, if you're resolving a query, you answering a call, and that's very operational. But the person that is actually driving the corporate strategy is sitting at the top. They might know what you do when they look at the transactions that you resolved on a daily basis, but what they are looking at is actually driving the strategy of that company. And when you look at that and how they think and how you think versus how you think at the bottom and the people at the tactical levels, that would be your project managers. They actually are using what I call the principles of abstraction. And these principles of abstraction really, if I try to just read, that is governance there at the top, and this is management, and this is, sorry, this is, I can't see that. This is management. I can't see that. Yeah, this is management principles, and this is scientific principles. This is the architecture that is keeping everything hanging in the balance. So we say we have people, so it's different people that are working in an organization who are trying to resolve something, who come from different perspectives, who hold different contexts, versus what the developer is going to write as a code that is actually going to drive specific transactions if we're looking at transactions. The NDDL, multi-agent optimization, is actually looking at 4 different agents. And the agent, if you were to think of an agent, we can just try and picture a person or an organism, any type of an organism that could be in a specific place, somewhere there on the mountain, and they're trying to locate where they are. And what they are looking for is to really find the minimum position. And if I'm talking about the minimum position, in this case, I'm actually talking about that river. So you could be sitting anywhere and you can't see the river if you're on the other side of that hill. This is the Alaska mountain, by the way, and this is the Alaska River, and the aerial picture was taken, it's a while ago. I actually asked for permission. And these, so the agents that I talk about, this is actually, it's using UML, the Unified Modeling Language. The agents, as you can see there, it's the positioner, which actually talks to that first variable we talked about, which has to do with discovery. Then it talks to the optimizer, and then it sends messages to the aggregator. The aggregator then talks to the integrator, which then tells the positioner where to go. As a positioner, I'm actually, think of yourself when you woke up this morning and you said, I wanted to get to the CSIR conference. You made that decision, and internally, so we could be having lots of interactions that are happening within you. Internally, you sensed, and you created messages, and you constructed the messages, and those messages were actually sent through to the optimizer, which actually talked to the construction of how you had this perceived path you were going to drive through to get to CSIR, or maybe take the Gautrain or take the taxi. And those messages are actually sent to the aggregator. And you can see when you're driving and we're looking at how the roads are built, there's governing mechanisms, and you have dotted lines. You can't cross a solid line if you're driving. You can't just drive into the next car. All of those things. This is 4IR in operation, and this is you understanding that you are operating in an environment that is very much integrated. And what happened is you send those messages back to the integrator, which then would do the calculations and come up with, it would be, for lack of a better word, it would be a statistical probability of whether or not you are staying in your lane, because you could be swerving off. If you're falling asleep, you could be driving off, and there's nothing that is stopping you. But then you also need to come back. And what you do is, because your eye is actually making contact with the real world, you keep on swerving with your car, and that is 4IR. The agents programming framework really, so we looked at the positioner and we looked at where we were sitting. And we are saying, so we can take any agent and say this is just agent B who's trying to, so agent B, if you look at agent B, the minimum position for agent B would be sitting somewhere there at the bottom. But agent B would use algorithms to actually find out where am I versus in the context of my surroundings. And what agent B does is it would create that So the positioner would send messages to the optimizer would then talk to the integrator, and then the integrator. And what we are looking at really, if you think about matrix programming, and so this is just a matrix, and it's all the information that is sitting in all of these agents, these different agents that send messages between each other so that we can contextualize and find out where we're sitting. It's really, the challenge with 4IR is that we have specific mathematical algorithms that actually seem to work. We don't understand how they work, and it's because they are driven by Markov principles. And Markov principles are actually statistically driven, which means you just calculate your next position based on your previous position. So what are the chances that when I walk this way, I'm not going to fall over? And how do I know that I actually have to move my leg to the left or to the right? And this is part of 4IR. We also look at, as part of this research, because we say we live in this integrated cluster. Unfortunately, in South Africa, we couldn't find a university that was actually researching on probabilistic databases. And if you think about probabilistic databases, really, it's just your relational model with appended with a probability of where you could be finding a specific attribute. But we, as researchers, what we don't want to do is we don't want to fiddle. We don't want to fiddle with the model that actually exists when it comes to current databases, but we want to complement them. That is why we talk about probabilistic databases. And if you look at what I've done is I just looked at how these agents actually talk to each other, and this is coupled with UML, but it's not clear at the moment. And you can see all the agents as they were introduced there and what they're trying to do, these specific things that they are trying to do, and how they actually come into play, and how this table below actually changes. This is the first, so this is this is what we use as part of discovery, and this is what the positioner does. And this is, I said, we are using UML to develop this algorithm. It's quite, I don't think it's complex, but this is what it looks like. It's not complex. Trust me, it's very easy. And these are actually messages that are actually sent back and forth, and how we make those derivations, and how we actually know which agent to talk to at what specific time. Because when you are trying to resolve a specific problem, you could find that there's no need to actually go to the next agent. You can actually resolve it within your context, because you know where you've been before. And when you wake up and people are talking about things that are natural, you don't have to think that you need to take a step to the left. You can even walk with your eyes closed in your house. But when you first move into your house, the first time around, and you don't know your house, what you'll do is you'll always try to navigate your way by using your senses. But when you know the place, you can actually just move around without really tripping over. This is what I call evolutionary thinking. And if you look at this now, this is the state machine. I think I saw one person raising a hand that they are developers, so they would understand what actually that thing means. But it's actually tied back to those 4 different agents and how they actually get instigated or invoked using all these different senses. What I showed you, the second UML activity diagram was actually just one of the agents. I do have other UML diagrams which they're quite easy. They're not as difficult as the first one, but they actually come back to this. And if you look at what is happening, I introduced leadership, I introduced risk optimization, I introduced geopolitical context, the evolution. This is the scientific rationale. The scientific rationale is really what drives the thinking or the philosophy that people use when they are trying to resolve systems. And with me coming from a township very close to Mthandeni, my philosophy is actually driven by my surroundings. And when I unpack all of these challenges, I actually use the background that I have in terms of mathematics, but I also have interacted with various people in my life that have actually shaped the person that I have become. And with you, you'd also be using different scientific rationale. And this would be driving a specific intent. Again, I hope you can read that. I'm not going to read that. But it is actually just summarizing all of this. And we are also just trying to contextualize what 4IR is. Maybe we shouldn't call it 4IR because I did say that it creates an impression that we'll have the 5th, the 6th, the 7th. But this is just artificial intelligence. And now artificial intelligence actually makes sense because we've coupled artificial intelligence with statistics and mathematics. So the fusion of all these different fields and understanding how to work with maths and look at statistics is actually giving us things that actually can help us visualize people. Like you can have a doctor sitting in Ukraine. I'll use Ukraine because this is where this was shared. You can have a doctor that is sitting in Ukraine performing an operation on someone who is in South Africa, and that is 4IR. That is artificial intelligence. We can actually understand what it means when we talk about this integrated cluster and what it means when we say this is going to change and shape all the fields. I think the problem we're facing is that our education system is actually very, very siloed. We have people who claim they are doing science, engineering, economics, but this is all integrated, and we should be thinking about ways of actually trying to integrate all of these fields so that we can drive knowledge and research. The integrative perspective is really just saying, if you think about that, so that's phylogenetic, which is really around the specialization, and ontogenetic and epigenetic there. And if you look at yourself, I said you are a particle that is living in a computational universe. And all of these are actually, we are trying to unpack these things using mathematics. And you could be a particle that is drifting around. I do apologize that you guys can't see this, but it is coming back again to those variables. This is when we can think of it from the, so I think what would make sense would be to try and contextualize what this model means in an organizational sense. Even though we can unpack this in any context, what we are looking at here is the industrial. I heard that we should be dropping the word industrial. Maybe not. This is the industrial intent optimization. This is the product intent optimization. This is the process. So this is, again, if you go back to that 3D model, we just unpacked the 3D model, and we are looking at it from a two-dimensional perspective now. We might have lost some of the accuracy, but this is the 2D perspective, and it helps people unpack. But if you are looking at that, we are just trying to drive or optimize some strategic intent. It could be any intent. When I mean any, it could be any intent. And it could be in nanoscience. It could be anything. But all of that is actually driven, and it's an integrated view of all of these, which actually go through all of these variables that I talked about, which is the discover, the construct, the govern, the manage. Unfortunately, you guys can't see this, but it makes sense in my world. I've been sitting with this for 3 years. It is perfect. And this is what we mean by the integrative framework. And when we say it's an integrative framework, we are saying you can use this to unpack a business problem. You can use this to unpack and perform research in biology, in physics. You can go to space, but we are saying everything should be optimized, and we should be looking at things as integrated and stop looking at these silos. So, because I saw this career as part of the topic that I had to talk about. Now, if you go back, wow. So this is, I said this is the industrial perspective, and this is the product perspective, this is the process perspective, and this is the project. Unfortunately, you guys can't see this, but this is the project intent optimization, and that's the scientific rationale. And you can see the leadership that we're talking about. It's leadership and risk optimization, geopolitical context, evolution and revolution. And you could, when we think about that evolution and revolution, again, I'll go back and say we can look at the first industrial revolution up to the current industrial revolution. But let's just say it is all artificial intelligence. But I think computational intelligence is actually making sense because it is contextualizing artificial intelligence, and it is bringing life to what people thought was artificial because we are computing things. And now, you'd read, when you go to the internet, you'd find people talking about the chief robotics officer. I don't think we need a chief robotics officer, because a chief robotics officer would be someone who actually moved up the ranks. And those people are actually, their view is very narrow, and they come from the organization itself. But we want researchers to be part of driving these organizations, because the researchers can actually see the future. And this is why we have the view that shows that we have the global context and we have the continental context as well as the national interest. And all of these, again, talk back to what we have. And this would actually change any of the career. It could be if you are a business analyst, if you are a programmer, if you are anything that you could be thinking of as a project manager. I think it would be worth your while to actually do a little bit of computational, not thinking, computational intelligence, and understand what statistics is and how it can be optimized in your own environment. And that would be your context, because what we are looking at is we are saying we can resolve these problems in any context. And that is my story, and I am sticking to it.